Hello everyone. So myself Shahbaz Ahmed, and I am here to teach you in this semester high voltage engineering, and me and Tavish Imtiaz, both of us are going to cover this subject. So let's have a look at the syllabus. So this subject comprises of 3 units. It is of credits. And three lectures are going to be held in each week, in which only one lecture should be taken by me and the rest of the 2 lectures should be taken by the Tabish Imtiaz sir. So let's have a look at unit number 1, because unit number 1 is going to cover by me, and unit 2 and unit 3 should be covered by Mr. Tabish Imtiaz. So this is the syllabus, in which unit number 1, the breakdown mechanism in dielectrics. The breakdown mechanism in dielectrics we are going to discuss. Mainly, what is dielectrics? You people know about, have heard the term insulation. So dielectric is a insulation, mainly in another terminology we can see that say that the insulation is also called as the dielectrics. And dielectrics, as you know, that the insulation medium can be of different types. Insulation medium can be a gaseous type, it can be air or another type of gases. And the insulation medium can be liquid, because some of the liquids are there which through which the current cannot pass through them, so they work as an insulator, as a dielectric. And of course, solid. Most we are very familiar with the solid dielectrics, also solid insulators, as in the daily life also we have seen that the wires and most of the cables are covered with the plastic, or at some places we provide the insulation with the wood and many more things. So this is the type of solid, the solid dielectrics we are familiar with. So in this unit we are going to discuss about the breakdown mechanism in those dielectrics. Okay, breakdown mechanism of those insulators. Okay, so we should have a look at a breakdown mechanism in gases. In the breakdown mechanism in gases, we are going to study about Townsend's theory, Steamer's theory. These are the two types of theories through which we should be able to know about that, how the breakdown takes place in the gases. And the breakdown mechanism electronegative gases, in which the Passion's law we are going to study. Then we come to the liquid dielectrics. So breakdown mechanism in the liquid dielectrics we are going to study, in which the suspended particle mechanism, cavitation, you must have about the cavity, the spaces which been created, and the bubbles mechanism, so due to which the dielectric strength weakens. So we are going to study about that. Stressed liquid volume mechanism. Okay, then we comes to the breakdown mechanism in solid. So in the breakdown mechanism of solid, we are going to discuss about the intrinsic breakdown, steamer breakdown, electromechanical breakdown, thermal breakdown. More, you are very familiar with this thermal breakdown. Thermal breakdown is simply that if we have a conductor, okay, most of the time you have seen that if there is a wire with a less cross-sectional area, and you are going to connect a heavy motor or anything with that, so a large amount of current is going to flow those that conductor. Then that conductor is unable to bear that amount of current, so somewhere that wire is going to burn. Okay, and so this is due to the rising temperature, because the more the current will flow, more will the temperature rise in the conductor, and more with the rise in the temperature, so it will going to burn that insulator. So thermal breakdown occurs, and then electrochemical breakdown is also one of the type. Tracking and treeing is also we are going to discuss in the solid dielectrics. Okay, so this is the first unit which we are going to discuss, and rest of the two units will be discussed by Tabish Imtiaz sir. Okay, so this is unit number 1. So first, in this lecture today, we are going to have just introductory, and this is the introductory lecture, so we are going to cover not in deep, only we are going to discuss few very common things. Okay, so वर्ल्ड ओवर, दुनिया में मतलब वर्ल्ड ओवर, द लेवल आर क्लासिफाइड एज लो, मीडियम, हाई, एक्स्ट्रा एंड अल्ट्रा हाई वोल्टेजेस. दीज वोल्टेज लेवल्स, यू हैव सीन दैट, जो आप लोग अपना डेली लाइफ में भी देखते हैं, दैट 220 वोल्ट्स इज़ कमिंग टू योर हाउसेज. उसके अलावा जो ऊपर जो आपके थ्री फेज 4 वायर सिस्टम होता है, तो 440 वोल्ट सप्लाई उसमें होती है. देन यू हैव 11 kV लाइन्स. Okay, 33 kV lines, these are very common in the city also. Then 66 kV lines you have heard about. In first year you have studied the layout diagram in the power system, तो उसमें आप देखते थे कि we are going to generate the electricity at 11 kV, तो उसके बाद step up transformers लगे होते थे. Then we step up to 132 kV और 400 kV और up to 765 kV maximum in India, because we have a maximum of 765 kilo voltage transmission lines in India. So in this way we have classified these voltage levels: low, medium, high, extra and ultra high voltages. But the exact magnitude of these levels vary from country to country, because there are the different standards which each country has maintained. So दुनिया में, पूरी दुनिया में there is not only one standard is maintained, so we can't we haven't mentioned the values of that. So in most of the world, even 440 volts as being written over here, 440 volt is also considered the high voltage, since it is dangerous for the living beings. As we all know that 440 voltage is also dangerous for the human living beings, so it is being also considered as a high voltage in some part of the world. Okay, so let's come to the voltage levels. So okay, now we are going to have a look at voltage levels. In that you can see that voltage levels, and at the consumer end we have 110 volts, 220 volts single phase lines. You must be well aware about that कि हमारे घरों के अंदर if you look कि 220 वोल्टेज लाइन आती है, which we use in our homes, और 110 वोल्टेज भी in some part of the world it is being utilized. जापान के अंदर and in USA there is 110 volts. Okay, and three phase 440 volts, 3.3 kV, 6.6 kV, 11 kV three phase lines are available there. Besides these voltage, the railway traction, only the railway traction is the one thing in which we are using 225 kV single phase, which is one of the biggest consumer of power spread at any particular stretch to 40 kilometer of track length. Okay, so 25 kV in a single phase is a big amount of voltages in a single phase. Okay, so then comes to the generation. If you come to the generation part, then you can see that in a three-phase synchronous generator in the power plants, we are generating the voltage. Small generators have 440 volts, 3.3 kV, 6.6 kV, which are the portable generators we see here. And then come to the 11 kV generators. 11 kV generators are those generators which are in the basically used in thermal power plants, and we also use 11 kV as a standard generating voltage. Okay, so 110 to 220 megawatt of unit is there. If then it is mostly assumed that it is generating 11 kV, rather than as I have told you earlier, might be I have told you earlier that 200 megawatt unit ka plant when I was visiting Raleigh, that is Shakti Nagar power plant, thermal power plant, and then the engineers have told me that it is generating approximately 15.2 kV of the voltages. And if it is at 500 megawatt of plant, then it is already written over here that it will generate 21.5 kV of the voltage. Similarly, 1000 megawatt of a unit is there, then 33 kV. 1000 megawatt unit is not here in India, but outside in many parts of the world it is being used. So we have this much of generating voltages. Okay, then we come to the distribution part. In distribution part, if we have three phase 440 volts, 3.3 kV, 6.6 kV, 11 kV, 33 kV, 66 kV. These are the lines we have, and the large transmission lines, or you can say that high ultra high voltage transmission lines. If we see, then as I have told you that we have in India, it is 765 kV line, which was first installed between Raichur and Sholapur. Then there is one place in the South India, Raichur and Sholapur transmission lines. It was first installed of 365 kV lines, because due to which all the five grids in India, that is the northern grid, east, west, and south and northeast grid, all the grids get synchronized. After which we have one India, one frequency. Okay, so we have synchronized that. Due to that, it was a 765 kV line, but in India now, the research is going on, 1000 kV and 1200 kV lines. Soon it is going to get installed. And with the increase in the power consumption density, the power distribution voltage levels are at rise, because the power handling capacity is proportional to the square of the voltage levels. But installation of these high voltage transmission line is not easy. It is very difficult. We should look at one or two videos also, in which we will understand that how difficult it is. So first of all, we should have a look at countries like USA, Canada, and Japan have their single phase AC power consumption level at 110 volts, whereas rest of the whole world consumes single phase AC power at 220 volts. The only advantage of 110 volt single phase consumer voltage is that it is safer. Okay, it is safer over 220 kV, but we have a lot of disadvantages. It requires double the magnitude of current to deliver the same amount of power as at 220 volts. Power is simply what a voltage into current. So if the current is going to get is the voltage is half, okay, instead of 220 volts, we are using 110 volts. If the voltage is going to get half, then the current is going to become twice of that. So if the current is twice, then we are going to have a large cross-sectional area of the conductor. If the cross-sectional area of the conductor, then the temperature rise should be more, and we want more insulation for that. So there are many parameters which are going to increase, and hence the same magnitude of I square R losses to limit the conductor or the insulation temperature to 70 degrees Celsius. The resistance of the distribution cable should be 4 times lower. Okay, the resistance should be less. If the resistance is not less, then you know that current is become twice and is square of that. So resistance should have to be 1/4 of that. Then only the same I square R loss is going to occur in that line. Therefore the cable cross section area has to be increased 4 folds. Okay, so this is also one of the disadvantages. So 4 times, if the cross section area of the cable is going to increase, 4 times more copper requirement dumped in the building walls is an expensive venture. So if the cross section area of the cable is increased, then you know that cables, तो आप लोगों ने इंजीनियरिंग कॉलेज वगैरह में भी और इन सब जगह पर देखी होगी, जो ब्लैक कलर की केबल्स वगैरह आपकी इंस्टॉल्ड होती हैं. तो अगर हम 110 वोल्ट इस्तेमाल करेंगे, तो केबल का क्रॉस सेक्शन एरिया जस्ट बिकम ट्वाइस ऑफ दैट. तो वो बहुत ज़्यादा हो जाएगा. बिल्डिंग के अंदर से जब वो गुजरेगा, तो उसके अराउंड जो मैग्नेटिक फील्ड डेवलप होगी, वो भी बहुत ज़्यादा हो जाएगी, विच इज़ हार्मफुल फॉर द हेल्थ. So due to the higher magnitude of the current, higher magnetic field in the buildings, which is not good for health. Okay, so with the installation of the modern and expensive protective devices, earth fault 220 volt is equally safe as 110 volts. Okay, so let's have a look at this, why we need to study all these things. So first we are going to have a look at the some parameters for insulation. It is important to understand the current and voltage carrying capacities of a conductor separately. Okay, while the current carrying capability is determined by the conductivity of the conductor, which is directly proportional to the area of conductor cross section, the voltage bearing capacity depends upon the level of insulation provided to the conductor. Okay, so the insulation is the main parameter over here. The current carrying capability in turn is determined by maximum permissible temperature of the insulation or that of the conductor. Maximum permissible temperature. So temperature is also very important parameter over here. So because I have told you earlier कि जो केबल होती है उसका इंसुलेशन जो होता है वो आपका प्लास्टिक वगैरह का बना हुआ होता है. तो अगर उसमें टेम्परेचर बहुत ज़्यादा राइज अप होगा, तो टेम्परेचर जब राइज होगा, हीट होगी, हीट डेवलप होगी, तो इंसुलेशन जो आपका प्लास्टिक का बना है इट विल स्टार्ट मेल्टिंग। जब वो स्टार्ट मेल्ट हो जाएगा तो उसका इंसुलेशन ख़राब हो जाएगा, जिसकी वजह से वी आर गोइंग टू हैव अ लॉट ऑफ लॉसेस। सो द रियल पावर लॉस I square R and the rate of cooling determine the temperature rise of the conductor, which should not be more than the maximum permissible temperature of the type of insulation provided to the on the conductor। तो ये हमारा होना चाहिए कि जो भी हमने कंडक्टर उसमें प्रोवाइड किया है, तो मैक्सिमम टेम्परेचर उससे ज़्यादा राइज नहीं करना चाहिए जितना वो बियर कर सके। हैंस नॉट ओनली इलेक्ट्रिकल बट थर्मल एंड मैकेनिकल प्रॉपर्टीज of insulation are important in power system। Okay, not only electrical but thermal and mechanical properties of insulation are important in power system। Okay, now let's come to the electrical insulation and dielectrics। So let's have a look at gaseous dielectrics। In the beginning I have told you there are three types of dielectrics: gaseous, mainly liquid, and the solid dielectrics। In the gaseous dielectrics we have mostly the atmospheric air is the cheapest and most widely used dielectric। Atmospheric air is the most cheapest and more because it is available everywhere, and is the most cheapest mostly and it is being widely used as a dielectric। Okay, and other gases dielectrics used as compressed gas at higher pressures than atmospheric in power system, which are nitrogen SF6 and its mixture with carbon dioxide, nitrogen, and SF6 is very widely applied for gas insulated system, circuit breakers and gas field installations, that is substations and cables. It is being not applied for power transformers also. It is being now applied for power transformers also। So let's have a brief look at the okay, later on we will see that. After that, vacuum is also used as a dielectric. The vacuum of the order of 10 to the minus 5 torr and lower provides an excellent electrical insulation। Okay, vacuum technology developed and applied for circuit breakers in the last 3 decades is phenomenal। And liquid dielectrics, organic liquid, the mineral insulating oils and impregnated compounds, natural and synthetic, of required physical, chemical, and electrical properties are used very widely in transformers। Okay, capacitors, cables, and circuit breakers, we use this liquid dielectrics। And then the solid dielectrics very widely used all around the world, in the daily life also you have seen, mostly we are aware of the solid dielectrics, which are XLPE, PVC, ceramics, glass, rubber, resins, reinforced plastics, polypropylene, impregnated paper, and etc etc it's mentioned over there। Introduction of nanomaterials are in offing. In future we are also going to see the nanomaterials as a dielectric material। Okay, so these are the three types mainly: gaseous, it is also one of that type, gaseous, liquid, and solid dielectrics we are going to discuss, and the breakdown mechanism in these dielectrics we are going to discuss one by one। Okay, so it is used because you know that dielectric and the insulating medium is very important in this, because in the high voltage transmission lines, as it is being mentioned over there, the atmospheric air is the insulating material, because if the insulating material or the dielectric is not available over there, then we know that जब ट्रांसमिशन लाइंस उसमें जा रही होंगी और उसके अराउंड जब करंट बहुत हाई वोल्टेज होगा तो उसकी प्रोपोर्शनली करंट होगा, जब करंट बहुत ज़्यादा हाई होगा तो उसके अराउंड उतनी मैग्नेटिक फील्ड डेवलप होगी, जब मैग्नेटिक फील्ड बहुत ज़्यादा डेवलप होगी तो आसपास जो दो कंडक्टर्स होंगे अगर वो शॉर्ट हो जाते हैं और करीब करीब होते हैं, वी आर अनेबल टू मेंटेन द मिनिमम डिस्टेंस बिटवीन दैट और द डाइलेक्ट्रिक स्ट्रेंथ बिकम वीक, तो उनके शॉर्ट सर्किट होने के चांसेस होते हैं। तो in the large in the cables or in the high voltage transmission lines, if the fault occur, then it is going to have a lot of losses over there, and there is a lot of manpower is being used to install all those things। So let's have one of the video to see that इसमें हम लोगों ने बस ये देखना है कि ये ट्रांसमिशन लाइंस जो आपकी जा रही हैं, इट इज़ द वीडियो ऑफ 1000 kV लाइन which is installed over the Yellow River in China. Okay, they have shown that how they are working, how difficult is this to work over there. So this is the height of the tower. It is on the across the Yellow River, which is approximately of the distance of 300 meters. These are the insulators. Okay, these are the insulators on which these wires are going through the insulators. तो ये देखिए, this is the height of a man, and this is only the single phase of that whole transmission line. This is the one phase in which 8 wires are going. ये क्योंकि 1000 kV है तो करंट का लेवल बहुत ज़्यादा हाई होगा, तो 8 कंडक्टर उन्होंने लगाए हैं. ओके, स्पेसर्स इसमें लगा देते हैं ताकि स्पेसर्स उसमें जब लगे होंगे तो स्पेसर्स की वजह से उसमें फ़ायदा ये रहेगा कि जब भी कभी भी विंड वगैरह या बहुत तेज़ हवा वगैरह चलेगी तो ये स्विंग करेंगे, तो ये आपस में टच नहीं करेंगे या बहुत ज़्यादा जो है वो जब तक ये जुड़े रहेंगे एक दूसरे से स्पेसर्स की मदद से. ये स्पेसर है आपका जो ये ले आकर लगा रहे हैं, हर 50 मीटर्स पर ये एक स्पेसर लगा रहे हैं. ओके, ये स्पेसर है आपका, ठीक है. ये एक स्पेसर जो यहाँ पर लगा रहे हैं, इसकी मदद से ये सारे वायर इसी तरह से जुड़े रहेंगे, मीन्स इसी डिस्टेंस के साथ. जब ये इसी डिस्टेंस के साथ जुड़े रहेंगे, दे आर कनेक्टेड इलेक्ट्रिकली, क्योंकि ये एक ही फेज़ है, बिकॉज ऑफ द लार्ज अमाउंट ऑफ द करंट फ्लोइंग दैट, इसलिए इसको अलग अलग कर दिया है, क्योंकि इतना इन सब को मिला के जो एक कंडक्टर बनेगा उसका क्रॉस सेक्शन एरिया बहुत ज़्यादा हो जाएगा. क्रॉस सेक्शन एरिया बहुत ज़्यादा हो जाएगा तो जो उस एक पर्टिकुलर वायर का वेट बहुत ज़्यादा हो जाएगा, जिससे इंस्टॉलेशन में बहुत ज़्यादा दिक्कत आएगी, जिससे कोरोना इफेक्ट बहुत ज़्यादा होगा. ठीक है, तो देर आर मैनी पैरामीटर्स विच वी हैव टू कंसिडर ड्यूरिंग द इंस्टॉलेशन ऑफ द ट्रांसमिशन लाइंस, जिसकी वजह से सिंगल फेस में ही ये अलग अलग कंडक्टर्स आपके लगाए हैं और स्पेसर्स से इसको ज्वाइन कर दिया जाता है ताकि जब हवा वगैरह तेज़ चले या विंड, आप जानते हैं इट इज़ अबव, इट इज़ 300 मीटर्स अबव द येलो रिवर लेवल, तो 300 मीटर ऊपर हवा का बहुत ज़्यादा प्रेशर होगा, ये स्विंग करेंगे, तो 50-50 मीटर की दूरी पर स्पेसर्स लगाते हैं जिससे ये स्विंग करें तो आपस में मूवमेंट ज़्यादा ना हो, क्योंकि जब ये आपस में जुड़े रहेंगे तो मूवमेंट इतना ज़्यादा नहीं होगा. सो आई जस्ट वांट टू शो दैट कि हाउ दे आर वर्किंग ओवर देयर, तो किस तरह से ये इतने लार्ज हाई वोल्टेज, अल्ट्रा हाई वोल्टेज ट्रांसमिशन लाइन जो है वो इंस्टॉल की जाती है. और ये एक सिंगल फेस है, और if we have a look at the other phase, so you can see that this is one phase and this is another phase, and look at the distance between them, because जब 1100 kV, ओके, 1100 kV वोल्टेज यहाँ फ्लो करेगा और यहाँ फ्लो करेगा तो उसका करंट यू कैन इमेजिन. अब जब करंट बहुत ज़्यादा हाई होगा तो उसके अराउंड जो मैग्नेटिक फील्ड डेवलप करेगी, यू कैन ऑल्सो इमेजिन, एंड यहाँ पर भी ऐसा ही होगा. तो इन दोनों के बीच में इतना स्पेस ज़रूरी है ताकि ये एयर एज अ डाइलेक्ट्रिक इज़ वर्किंग ओवर हेयर, तो ताकि इसमें कंडक्ट ना हो. अगर ये इसका डाइलेक्ट्रिक ब्रेक हो गया, मीन्स अगर ये कंडक्ट करने लगा तो शॉर्ट सर्किट होगा, तो यू कैन इमेजिन द लॉस. ओके, तो इसलिए डाइलेक्ट्रिक और द डिस्टेंस बिटवीन द केबल्स to maintain the minimum distance between the cables is very important parameter in that. So these are all parameters which we have to keep in mind before the installation of the cables and all that. And we are going to discuss about the gaseous dielectrics on the next turn, the breakdown mechanism in the gaseous dielectrics. Okay, so in this lecture we have this much only, and we are going to discuss on the next turn here about the breakdown mechanism, gaseous dielectrics. Okay, thank you, thanks a lot.